3 looks at solving these linear systems through algebra. And with lesson 3 specifically, we're looking at substitution. So there's a flow chart of what you can do that walks you through the steps. Before we look at that flow chart in depth, we're just going to jump into the first problem. So the key to remember when you're looking at these equations is if we go back to some of the notions of equality that we've had from in the past. Things like if 2 plus 5 equals 7 and 3 plus 4 equals 7, what conclusion can you draw from that statement? The conclusion being that 2 plus 5 has to equal 3 plus 4 because the two equations balance. Okay? So if I look at the system of equations that I have here, I have x plus 4y equals 17 and 2x minus y equals 7. So if we were to rewrite the first equation as an x equals, isolate x. So that means we throw the 4y over. X would equal negative 4y plus 17. Now if I look at this second equation, well, the second equation being 2x minus y equals 7. Well, if the two equations are solved, that means that they have a common point, which means the point that I put into this equation would also fit into this equation. So what it means is I can do a substitution. Instead of writing x in this equation here, I can substitute it with this statement. Because x is equal to the negative 4y plus 17, and x is going to be the same in both equations for the solution. So I can substitute in, and what I get is now an equation in one variable. I no longer have a two-variable equation. I now have an equation that is just in y. This is the equation that I can solve. So I'd start off by removing the brackets, and I'd have negative 8y plus 34 minus y equals 7. I would collect the like terms, so I now have a negative 9y plus 34 equals 7. I'd move the 34 over through subtraction, and I'd get negative 9y equals negative 27. Divide both sides by negative 9, and I would get that y is equal to 3. So I now have a y solution, which I can substitute into either one of the two original equations and solve for x. So if I put it into the first equation, seeing how my x only has one for a coefficient, 4 times 3 equals 17. So x plus 12 equals 17, which means x would equal 5. So the solution to this system would be 5 and 3. And I could do this, I could isolate for y as well. If I'm going to isolate for y, I'm going to pick the second equation because my coefficient for y is a 1, and I'm not going to worry about fractions. So I can move the y to the other side, and I would get 2x minus 7 equals y. The y would go over to become positive, and then I'd bring the 7 over to make it negative. Then what I would do with this equation is I would substitute it into my first equation. So I isolate for a variable in one equation, and then I substitute it into the other equation. So if I substitute in for y a 2x minus 7, I once again get a statement in which I only have one variable. And then we're back to using all of the methods that we learned in the past couple of years. So I get x plus 8x minus 28 equals 17. Add the x's together and I get 9x minus 28 equals 17. Add 28 to each side 9x would equal 45. Divide by 9, and I get that x equals 5, which is what we got in the previous question. So then I can take that 5 and substitute it into either equation and solve for, or sorry, take the 5, substitute it in for x, and then solve for y. So if I put that into the second equation, I get 2 times 5 minus y equals 7. Move the y over to the other side to make it positive. Bring the 7 over, and I get that y equals 3. So I still get the same solution of 5 and 3 in the end. So it doesn't matter, again, which equation you decide to isolate and which equation you decide to substitute in. You'll still get the same solution. And then if we verify that this solution satisfies both equations, I have x plus 4y has to be equal to 17. X is 5, y is 3, so I get 5 plus 12, which is equal to 17. So it satisfies the one equation. Now if I put it into the other equation, I have 2x minus y is supposed to equal 7. So I have 2 times 5 minus 3. So I get 10 minus 3, which also equals 7. So now if we go back and we look at this flow chart, choose the simpler equation and express one variable in terms of the other. When they say choose the simpler equation, what they mean is we're looking for a coefficient, that's the number in front of the variable, of 1, a positive or a negative 1. That's what it means by choosing the simpler equation. If you do not have an equation where it's positive or where it's a 1, then you would try to choose the next simplest equation. Then you're going to isolate that variable, so express one variable in terms of the other, so express it as a x equals or a y equals. Substitute that expression into the other one, which gives you a single variable equation that you can now solve. Then you're going to substitute it into one of the original equations to solve for the other variable. So here's your next equation. So if I look at this one, I've got 4x plus 3y equals 0, and then I have 8x minus 9y equals 5. So I don't have one here that has a coefficient of 1. So the next simplest equation, probably this one, because I only have an x and a y. I don't have a constant to worry about. So from there, doesn't matter which way you decide to do this. What I would probably do is I would probably isolate x. So I'd have 4x would be equal to a negative 3y. Divide by x, and I get negative 3/4 y, which in this case, I might actually even write as a decimal. I might find it a bit easier to express that as, actually no, I'd still find it the same if I left it as a fraction. Then I would put that fraction or that variable into the next equation. So where I see an x in this equation, I will substitute it in for this. So I get 8 times negative 3/4 y minus 9y will be equal to 5. So now again, I only have one variable. When I go to multiply this out, 8 divided by 4 is 2 times negative 3, and I get a negative 6y minus 9y equals 5. Combine these together, I get a negative 15y equals 5. Divide by negative 15, and I get a negative, or sorry, I get a positive. Let's do that again. 5 divided by negative 15 gives me a negative 1/3. So now that I have my answer for y equals negative 1/3, I can substitute that into my equation here with x. I get negative 3/4 times negative 1/3, and I get for an answer 1/4. quarter. So then my solution would be 1/4 and -1/3. And I will let you take your own time to put that in on a graphing calculator and verify it using a graphing calculator. So now if we look at the last question, okay, so if we take a look at this last question, in order to start off with this question, the first thing I'm going to need to do is remove the brackets on these two equations. So I'll have 10a minus 15 plus b equals 5. And if I put the 15 over to the other side, which would make it positive, I would have 20. So take a couple of moments, pause, and do the second equation. So with the second equation, 6a minus 2b plus 8 equals 20. So 6a minus 2b would equal 12, because I would have to move that 8 over. And in this case here, because everything here can be divided by 2, I could actually simplify this further by dividing everything by 2 and getting to this equation, 3a minus b equals 6. Now from here, I can pick either of these two equations to isolate, because in this case here, the b exponent, or the b value is 1 in each of them. So if I decided to isolate this equation, I'd have b equals negative 10a plus 20. So then I could slide that equation into the next one, and I'd have 3a minus this negative 10a plus 20 equals 6. This minus, think of it as being a -1 coefficient being multiplied by everything inside the brackets. And now I can combine these two values. I get a 13a equals 26. Divide both sides by 13, and I have that a is equal to 2. And then I can put that a into either one of these two equations to solve for b. So b equals negative 10 times 2 plus 20. And I actually get 0. So I have that b is equal to 0. So then my solution, a equals 20, b equals 0. If I verify this algebraically, I want to verify this in the original equation. So 5 times 2 times 2 minus 3 plus 0 has to be equal to 5. So 2 times 2 is 4. 4 minus 3 is 1 plus 0. And I get 5. So it works in the first equation. Now I put it into the second equation. 6 times 2 minus 2 times 0 minus 4 is supposed to equal 20. So 6 times 2 is 12. And then here I've got a -2, and this would be a -4, which would give me a positive 8. And 12 plus 8 would then equal 20. So I verified that the solution matches both equations. So the questions that I would like you to practice with are question 1, A and D, 2, B and D,